Now we are going to learn a new coordinate system called polar coordinate system. Well, before going into this new system, let me briefly go over the previous Cartesian coordinate system that we have been using so far. So for the Cartesian system, what we do is, if we need to mention the position of a given point, then we measure. Now let's say the given point is somewhere here, then we measure the distance in this x-axis and the distance from the y-axis. Let's say if this is 5 and 8, then we write the position as a coordinate pair, and 5 represents the x-axis distance and 8 represents the y-axis distance. Now here in this Cartesian system, there is an important thing that you have to understand. That is about the positioning of this origin. So here what you should keep in mind is that the position of the origin will totally depend on our choice. Say for example, if we have let's say if we have few objects positioned in some place like this, right? Let's say if we have things like this. So say for example, if these are planets, right, and if this is the Earth, and if we need to mention the position of the other planets with respect to the Earth, or these points need not to be planets always, right? It's just some objects. So if you need to mention these positions, one way that we can do is, we can define our origin as the Earth or some object, right? And then we can draw two axes, one horizontal and one vertical, but it should be perpendicular to the previous axis that we draw, right? And then at this intersecting point, we can name, or we can define this intersecting point as the origin, right? 0, 0 point. So in our case, we draw these lines in a way that the intersecting point coincides with this chosen object, which is Earth in this case. So let's say this Earth is exactly positioned on this intersecting point, but in this diagram that I drew, it's a little bit off, but if we need to be precise, this point should lie on the exact origin. Okay, so now according to this defined origin, we can measure the distance along this axis. Now if we need to give the position of this one, we can measure the distance along this axis. Let's name it as the axis number 1, and we can measure the distance along this axis, which is number 2, and then we can mark these two distances. Let's say if this is 10 and if this is 20, so we can mark the two distances as a pair, and in this pair, the first number will represent the distance along this axis, and the second number will represent the distance along the other axis, right? And the convention is to name this first axis as x and the second axis as y, right? And but the thing is, it is not a must to have the origin at this place all the time, right? Now some other person can define the origin at this point, right? Then we have to mention the position of all the other objects with respect to this new origin. So this becomes 0, 0, and if we need to mention the details of this same object, then we have to measure the distance along this axis and this axis, right? Which will be, now accordingly this axis will have a value, let's say 100, and this axis will have a value something like this. So according to this origin, the positioning of this object will be 100, 150, right? See, it's the same object, but depending on the choice of the origin, this x and y coordinate will change, right? Now even you can select the origin to be this point, right? So then the x and y coordinate of that particular point will be 0, 0, right? See, it's the same object, but depending on the position of the origin, the coordinates will change. So the main idea you have to extract from this explanation is that the choice of the origin in the Cartesian coordinate system is totally up to us, right? We can define wherever we need as the origin, and with respect to that origin we mention the position of the other objects, right? So, and for the Cartesian system, what we do is we choose a particular place as the origin, and then draw two perpendicular axes that will intersect at this chosen point, and we name this point as the origin, and we give its coordinate as 0, 0, and then we measure distances along these two axes and mark the positioning of the other objects as a pair like this, right? So that's the basic method to obtain the Cartesian coordinates of a given point, right? And for the polar coordinate system, it is a bit different, right? Now let's say we have few objects like this, right? Then for the Cartesian, not for the Cartesian, for the polar coordinate system, what we do is we choose, now as it was in the Cartesian system, we choose a particular point, right? Let's say if we choose this one, and we name that center point as the pole, not the origin, okay? We name this as the pole. And then what we do is we draw a single line starting at that pole, at that defined pole, right? So we draw a line like this, right? Now remember in the in the Cartesian system, once we define this center point origin, we draw a line across that point, right? But here in the polar system, this line do not extend to the other direction, right? It goes only for a one particular direction only, and also there is only one line, right? And then once you draw this line, in order to mark the positioning of the other objects, what we do is Now let's say if we need to mark the position of this object, what we do is we kind of draw a straight line starting from the pole, right? And then we measure this angle, right? Let's name it as theta. And then we measure this distance, right? Let's name it as r. Then for the positioning of this object, we mention the r value and the theta value, right? So this is the way that we give the positioning of an object in the polar coordinate system. So now you have to clearly identify the difference between the Cartesian system and the polar system, right? And also very important thing that you have to recognize is about this positioning of these center points, right? We have the choice of defining these poles in the polar coordinate system and the origin in the Cartesian system. And also these are two distinct systems, right? So one system is not like, it does not depend on the other system. They are totally two independent systems, right? Now also this line, it need not to be horizontal all the time, right? Now let's say if you have if you have drawn the line like this, right, then you will, in order to mark this number, this object, we have to measure the distance from this line, right? Then that theta along with this given r now will give the position of the same object with respect to this line along with this pole. And if we choose this one as the pole, and if we draw a certain line, then we have to do the same thing but with respect to that assigned pole, right? And there are some more conventions that you have to learn. Now remember, in the Cartesian system we defined the coordinates of the origin as 0, 0, right? And for the polar system, coordinate of the pole is a bit strange, because now as you can see, if r is 0, right, we have the option of giving any theta value, right? So if the r coordinate is 0, no matter what theta you mention, it refers to the pole, right? So that's a bit strange, right? Because now in the Cartesian system that we used to have, that we were using before, had only a unique representation for the origin, right? So 0, 0 is the only way to represent the origin in the Cartesian system. But here in the polar coordinate system, this pole can be represented in kind of infinitely many ways, right? So the only requirement for the coordinate of the pole is to have 0 as the position of the r value. And so say for example 0 pi by 4 and 0 pi by 2 will both represent the pole, right? So this is the deciding factor for the coordinate of the pole, right? And then there is another convention. Now see, once you define this straight line, there are two ways that you can measure the angle, right? One way is the this anti-clockwise direction, and the other way is to measure the angle in the clockwise direction. That is also possible, right? So the convention is, if we measure the angle in the anti-clockwise direction, that is the direction opposite to the movement of the clock, right? So the hands of the clock will move in this direction. So this is called the clockwise direction, and the anti-clockwise direction is the opposite way, right? So if we measure the angles in the anti-clockwise direction, we represent it with the positive sign, and if we measure it in the anti-clockwise direction, we mention it in the with a negative sign. Say for example, if we have this as the origin, right, 0 theta, and let's say if, you have a point somewhere here, and in order to mention that point, let's say if r is equal to 2, and if, let's name this angle as 90, right? So if we measure the angle in the anti-clockwise direction, the coordinate of this point will be 2 comma pi by 2, right? See, the radius or this distance comma the value of the angle. Or else you can go to the same point in the clockwise direction, right? So then the coordinate will be negative 3 pi by 2, right? So now this is an important thing, right? Like, I mean, as a main difference between the Cartesian system and the polar system is that the given points has different representations for the positioning, right? So here, if you measure the angle in this direction, you have this representation, and if you measure the angle in this direction, you have this representation. And this is important, okay? If it is clockwise, you mention the angle with a negative sign. And one more thing, now let's say if this is the polar system, and then let's say if we have an object at this point, right? So what we can do is, in order to give the polar coordinates of this point, what we can do is we first draw a straight line starting from the pole towards this point, and then we measure this distance, right? And then we draw an angle starting from this point. Let's say if we draw it in the anti-clockwise direction, we have something like this, right? So we mention this one with the angle theta, and you have r theta value, or else you can measure it in the clockwise direction, but if so, you have to mark the angle with the negative sign. And now for this one, there is another way of representing, right? Well, let's say if we extend this line, right? Now if we extend this line, and if we mark the same distance on this line, right, there will be a certain angle, right? And let's name this as theta 0, and let's name this as theta 1. Then the position of this object will be r theta 0, right? And this object will be r theta 1, right? R theta 1, because this angle is theta 1. But see, you like these two objects lie on the same line, right? The only difference is with this angle. So there is a method in the polar coordinate system to mention one point with respect to the other, right? Now that means if we know the exact coordinates of this point, right, let's say if that is 2 and pi by 3, then we don't have to find this angle once again. So what we can do is, if this distance is also r, that means 2, what we can do is we can rewrite the coordinate as negative 2 pi by 3, right? So that means first we have a 2 pi by 3 point, and then we make the direction of r in the opposite way, right? Now, or else let's say if we have the same system, and let's say if we know the distance and the radius at this point, right, let's say if this is 3 and let's have this angle as 4 pi over 3, then the coordinate of this point will be equal to 3 4 pi over 3, right? So this is the radius and this is the angle, and if we make the opposite direction, right, this should be on a straight line, right? It should be on like exact straight line, and if you have the same distance, that is r equals to 3, now we don't have to measure this angle one more time, right? Like if we know the angle at this position, then what we can do is we can rewrite this point also along with this angle, but to mention that you are making this distance in the opposite direction, you have to write down negative 3, right? Now you should not misunderstand this notation thinking that negative r values will only be on this side, right? That is not true, right? Negative r values can also take place in these places as well, right? It need not to be below this straight line always, right? You can have the negative values in this upper direction or upper quadrants as well, right? So the only requirement for this negative representation is to have a certain point, and if we are using the same angle for the same distance but in the opposite sense, then you should be using the negative angles, right? Now I will do another example. Let's say if we have a point at here, if you have a point in here, let's have the radius as 5 and the angle as theta 2, that's something greater than 90 and less than 180, right? And if we extend this line and measure a distance of 5 units, what we can do is we can write the radius as negative 5 and use the same angle. Or if we have a point in here with a certain radius, let's say 8, and with another angle, and so this angle will be the value of this one, right? So, and if we extend this line in the backward direction, and if we get the distance r, which is equal to 8, then you can represent this point, the position of this point, as negative r theta by 4, or else you can separately measure this angle and write it as positive r with this new angle theta 5, right? So you have to clearly understand that this negative r means you are just making another point in the opposite sense.